Hello, ladies and gentlemen. Welcome to this episode of our journey on groundwater. That's our studies on groundwater. As we know, this platform is to educate everybody about groundwater here in Ghana, especially and beyond. I would like to first of all say that we are very grateful for your support. Thanks for your comment, your subscription, and then the likes that you have. Please, I want to say that don't cease. If you are yet to subscribe to this video and then like the videos, all the videos on this channel. Please do to watch all of them, like them, subscribe to this channel, and then share it with everybody. In fact, that's one of the things we are trying to share knowledge and then educate ourselves on groundwater and what there is to know about groundwater. So please share it with everybody and send in your comments. We want more comments. Any idea that you have. Whatever questions that you have that you is on you, it's on your mind that you want to ask, whatever you want to send to us, send it to us. And if there is a particular thing that you want to understand, just send it, and then we will reply you so that we all educate ourselves on groundwater. So today, what we want to look at is whether we can find groundwater everywhere or anywhere at all, whether we drill anywhere at all, whether we can get water. That's the focus for today. And to begin with, what I would say is that it is a big fat no. We cannot get groundwater everywhere. It is not, that the case. That is not the case. And one thing I want to say is that even where your foot, your 2 feet are, can be very, very different. It may happen that your right foot is in a different geological terrain or on different rock, different kinds of rock with different characteristics from the left. And when we drill deep down, when we dig deep down, they may be in different geologic formation on different rock types. So on the basis of that, it means that we cannot get groundwater everywhere. You may drill the right place and then get groundwater there, but the left will give you, though they are in the same environment, everything is the same. So that is not the case. And there are other contributing factors that leads to us. In our previous video, we talked about where groundwater can be found, some of the things that can happen. You know, Normally, when rocks weather, they become smaller particles, and when it rains, it goes through these smaller particles that we call soil. And this soil, too, depending on their texture, their grain size, their grain shape, and all the characteristics of soil, it depends on depending on them. It allows much more water or restrict them. So for instance, let's say clay is finer, very finer, and it is interlocking. They have interlocking grain. The grains are the particles of soil, so they interlock very well. So they don't allow water to come out of it easily. It can collect water. Water can get into it, but they don't allow water to come out of it easily. So those are some of the. But let's say a sand. Erosion soil. Those are normally they are made up of quartz. So with those, I see that they are very loose. They are not that compact. They are not interlocking. So for that one, when water gets into it, it just drains like that. It is unable to hold water. So it is porous and permeable. But clays are porous but not permeable. They can collect water, they can support water, collect water, but they don't allow it to come out of it easily. So in that, you realize that groundwater cannot be gotten everywhere. And another thing has to do with rocks. We can also get water in rocks. And this happens when the rock have structures in them, structures such as fractures and their dies or their folds and all that. And then we have different types of food, which I'll be talking about in a minute. So in some few moments. So all these things contribute in the collection of water or whether water can get into or can be found at a particular place. So all this, the characteristics of the rock, the characteristics of the soil, and all that, where they are found can determine whether groundwater can be gotten somewhere or not. And some people may even ask if groundwater can be gotten in valleys or whether they cannot be gotten or we cannot get groundwater in hills. It is not always the case that you get groundwater in valleys. Yeah, valleys may collect water, but it's not always the case. You may drill a valley um, and get dry wells, and you may even go to a hill, drill there, and you get water. No, normally what happens is this. I'm coming to demonstrate this as a result of the fold that I mentioned earlier on. We have different kinds of folds. So we have anticlines and syncline, and I'll demonstrate with this rule. You know, when you have something like this, a rock bends like this, we call it an anticline, and when it bends like this, we call it a syncline. So you can see that when there is a road construction, they cut through a hill or a mountain. You can see some drawings, some things on the surface where it has been cut, as if it has gotten some zigzag kind of form. Those are folds. Those are typical folds, and most of them, you see that the rocks are in that kind of zigzag, goes like this, bends and all that. So let's say that we have an anticline like this. And then the anticline is like this. And then we have soil particles, erosions, which has piled on it over time. And it has formed something like a U like this. A U like, so let's say the anticline is an inverted U, like the rule here. And then we have a U, a normal U like this on top of it. You realize that the thickness from where and the thickness from this point, which is, let's say, the rock that has folded, to that lower portion of the valley, or that lower portion, you see that the thickness is not that great. So water may collect there, but it may not be enough. And this one too, it is impermeable. Water cannot go through it. Water cannot go through. So the water will collect in this column alone. In this column. So when you drill here, you realize that you may not get enough water, or you may not get water at all. But let's say that we have a syncline like this U, and then even with the syncline U like this, we have a pile of soil which has formed a hill on it, You see that when you drill, because of the depth of the hill to the bottom of the syncline, you realize that it is so much. Even if it's flat, you realize that the depth is so great, more than the first one that I showed. So with this situation, you realize that you can get water, much water, on a hill. you know there can be this thing, the anticline and fold too can also form under some hill. It cannot perhaps happen, but I'm saying I'm putting up a situation where we have anticlinal and a hill on the syncline. You see that you can get a lot of water. So we can also have a valley with a syncline like this, it also hold so much water, but it is not always the case that we will have water, or you can get groundwater in valleys. So these are some of the things. These are types of foods, and the other situations that contribute to that. So one other thing that we have to also look at is where we get water, or the regional geologic formation in the country. And we have to understand that Ghana is basically made up of major groups of rocks, or formations. We have the first one, which is the Votanian formation, with the Votanian supergroup. The Votanian formation covers a portion of the Upper East region towards getting closer to the Upper West, and then down south throughout the northern region, and smaller, getting closer to the savannah, but it goes through and then comes down south. And it covers 40% of the land mass of Ghana, 40% of the land mass of Ghana. And in this terrain, it is very difficult to get groundwater because of an event we call the Pan-African erosion, which causes changes in the rock, in the characteristics of the rock. So it is very difficult. So in the northern region, we realize that most parts of the more northern region, getting south to the Volta region, and it's very difficult to get groundwater in these areas. Most of these areas, so it is quite, the Votian formation is not an easy terrain for groundwater success. So with this one, um, the nature of the rock comes into play, and then it doesn't support groundwater. And even the site investigation is done in differently than other parts of the country. So the northern part, within the Votian formation, north towards the southeastern of Ghana is quite a difficult terrain to work in. And another portion or another type of rock that we have, another major one, which forms about 23% of the landmass of Ghana, is the Birimian Formation. The Birimian Formation, which is the oldest rock group or the rock types that we have in Ghana. They are the oldest, and it's followed by the Votian Formation. So within this group, it is much more easier. And in this formation, that or the Birimian supergroup, that's where we have all the good mineralization in Ghana, all the good mineralization. That's where we have it. So you see that it starts from somewhere, some part of the upper part of the uh, upper east region towards the upper west region, coming down to the Savannah region, and then to the Bono, and then down south towards the Ashanti region, all those areas, getting to the western region, central part of the central region. So I'll do a particular video on this one, especially when it comes to Galamsey, so that we can have a full understanding of the influence of the Galamsey activities on groundwater and all on water bodies generally in Ghana and their effect. So as a result of um, folding and other folding or the geological structures, there are many in this kind of the Birimian formation. So you realize that we can get lots of groundwater within this terrain. Groundwater is easily gotten in the Birimian supergroup than much than the Votian formation or supergroup. So that is it about the two major rocks. And the other one, we have the Aquarian Formation, we have the Secondian, all those areas too are there. Now let's get to the Greater Accra region where I stay, in fact. Getting water in the Greater Accra region, not all portion can be, we cannot get water from all the spaces, all the areas in the Greater Accra region. No. Some places are very, very difficult, and some places are much easier. Now, let's take the eastern part, let's say the western part of the Greater Accra region. Let's say the Ganwes, Kaswa, Ganwes. That's when I say Ganwes, I mean Amasaman, Dantra, those areas. Let's say Ajen Kutuku, getting towards um, the western part of the Greater Accra region, the far west. These are areas within the Suhum Basin, and the Suhum Basin is made up of granitic materials. So it is much easier. I mean, the success rate is moderate, about 60%. So it's moderate. You can get water maybe 50 liters per minute within these areas, within this area. So it is better. You can get water here. So when you drill, but that doesn't mean that you can get it even within the granitic or the Suhum Basin. You can get it everywhere. You can drill a place and you not get it at all. Even with all the sophistication in siting, you may get a driver, but the success rate is moderate. You can the success rate, which is like I mentioned earlier, is about 60%. Now, when we come to the another portion, we call the Togo quartzite, the Otto quartzite, and the phyllite. You know, um, this place, because of the folding and the fractures and all, the success rate is very, very high. 70% and above, over 70%. So here you can get lots of groundwater, and even, I mean, you can even get artesian well. You can get artesian well, you can get lots of water, and then you can get even 80 liters per minute and above. I mean, you can even get even up to 400 liters per minute. It is very, very, the success rate is very, very high. That doesn't mean that you may not get a dry well. It can happen that you get a dry well, but this area is known to have very, very successful rates, and you can find this area like from Pokwase, Ofanko, Kwabenya, let's say Ghana Atomic Energy area, those areas, yeah. And we have some pockets too, like the Bema Camp, the airport area, we have it there. And then, yeah, those are some of you can get it around those areas. So these areas have very high success rates. And we have another one to the far to the east, to the eastern part of the region. We call it the Dahumeyan formation. This is a very difficult terrain, very, very difficult. You know, the success rate in this area is very low, very, very low. 40 less than 40%. So getting dry well in this area is highly, very, very prevalent. So and the yield is around it's less than 30 liters. I mean 30 liters and below. You don't get much money, much yield. So it is very difficult. And these areas are from Medina going to Sege area, Dowenya, Tema, getting to the Sege, Adan, Kase areas. I mean, yeah. So these areas, you don't expect to get much more groundwater from this area. They are very, very difficult in the region. So I hope this has also given us a fair idea about how groundwater can be found, you know. So, as I mentioned in a previous video, that I'll be going live on how to go about groundwater and all that on 15th. I would like to, play with you, crave your indulgence that let us shift it a day, a day this thing after the 15th, that's 16th October. So I'll be going live on 16th October um, to do a presentation on how the processes are done to get groundwater. And please, the reason why it has been shifted is because a very, very important event that I'm supposed to attend will be happening on 15th October. So please bear with me. Bear with me so that we can do this. So 16th October, you'll be going live and we'll do a presentation on the process that are involved in getting groundwater. So please don't forget to like the videos. Don't forget to subscribe to the channel. Don't forget also to comments and then share with everybody. Share with everybody. That's we want to educate the entire everybody or the number that we can get as far as we can go. Let us educate people on groundwater. So till I see you again, I'll say a very goodbye.